Hi, this is John Marsh here, doing some example problems, homework 3 from NCS 210. Which was chapter 3 of Forouzan problems 18, 19, 20, 23, and 31. Okay, I'll start with number 18. And in this problem, problem statement is that the bandwidth of the channel is 5 kilobits per second. How long does it take to send a frame of 100,000 bits? Okay, so we use the word bandwidth and data rate sometimes sort of interchangeably, but this one says kilobits per second, so I'm going to write this down as a data rate, and I use R with the subscript B for data rate, and I'm going to write 5 kilobits per second, and I'm going to immediately write down 5e3 bits per second. Okay, a kilo is an E3, and then I'll write down that the number of bits is 100,000, or 1e5 bits, and the question is T total, the time to send n bits is equal to what? Well, we know fundamentally that n, the number of bits, is the data rate times the total time. Bits per second and seconds. And so I can solve for t here. T total is equal to the number of bits divided by the bit rate. So it's 1e5 over 5e3. Okay, and so this is 100,000 divided by 5,000. 100 divided by 5, which is 20 seconds. Okay, that's problem number 18. And let's see, does this make any sense? 5,000 per second, we need to send 100,000, yeah, 20 seconds. It makes sense. 3.19, the problem statement is the light, this is the light from the sun, 8 minutes to reach the earth. What's the distance between the sun and the earth? Well, the total time is 8 minutes. And right away I'm going to write 8 minutes times conversion factor, 60 seconds per minute. The minutes cancel and I get 480 seconds. Okay, and the velocity is the speed of light, which is 3 times 10 to the 8th meters per second. Okay, so this is the light in the vacuum between, or in the free space between the earth and the sun. And we know that the distance is the velocity times the time. Okay, and so I just multiply these two numbers they give me. 3 times 10 to the 8th times 480 seconds is 144 times 10 to the 9th meters, or 1.44 times 10 to the 11th meters. If we want to put it in terms of kilometers, we just subtract 3. 1.44 times 10 to the 8th kilometers. Okay? And so that's 18 and 19. Let's move on and do 20. And in 3.20, they say a signal has a wavelength of 1 micrometer in air. How far can the front of the wave travel during 1,000 periods? And so what I'll do is I'll say that lambda is 1 micrometer, or 1e minus 6 meters. And the total amount of time that we're talking about here is 1,000 t, where t is equal to the period. Okay? And, well, we know, we're asking how far does this thing go? Well, we know that a wave travels one wavelength in one period. Let me write that down. And so in 1,000 periods, it's going to go in 1,000 wavelengths. Okay, so a distance is 1,000 lambda, which is 1,000 times 1e minus 6 meters, or 1e minus 3 meters, or 1 millimeter. Okay, so you can draw sort of a picture of this. Here's the transmitter, and after time, at time t is equal to t, if we draw the x-axis here of distance, it's gone 1 wavelength. If after time t is equal to 2 periods, now we've got 2 wavelengths have been sent out with this thing. Okay, and so this is a great conceptual problem, and it'll go 1,000 periods, or 1,000 micrometers, which is 1 millimeter in that time. Okay, I think I can do another problem. Actually, I'll make another video for the last 2 problems. So here's problems 18, 19, and 20 from homework 3.